Thank you. Our next speaker is Nick Silkey from Yale University. He's a Unix system administrator, and we'll be talking about scaling your Drupal.
Sort of real quick, I assume everyone knows what Drupal is. How many people there actually actively support it and maintain it? Just one, two, sort of, four. So, real quick, sort of a little bit about me. I started working for Yale probably about 2 years ago. Before that, I worked at the University of Texas. One of the things that's kind of really cool and engaging about my group at Yale is that we have a group of us here they are really sort of fascinated about how to scale things out, fault tolerance, and also automate everything we can. Because the best system is, of course, a lazy system. So, where this all kind of got started, there was really sort of no centralized, agreed upon enterprise content management system at the university as a whole. So we actually had a mishmash of stuff. The top level stuff that actually powers Yale Edu. Absolutely zero web frameworks there. It's all it's about 300 gigs of static Apache stuff. As far as learning management goes, we're one of the only non-Blackboard edus. We contribute code actually to the Silkey project. We have a lot of J2EE developers there who help power that. But we still had a lot of mess external to the top level domain and learning management system. There's several like WordPress installs out there in the wild in like the academic environment. People use Confluence for wikis in multiple disparate locations. The med school, actually, they used to be two separate IT organizations. Prior to me joining there, they merged. The med school had a humongous, beastly scary LAMP stack running on True 64 alphas. It's still running there. So Drupal's like our migration platform to get the n number of namespaces that currently live there off of the LAMP. But then there are also people at Yale, research organizations, laboratories, and other sort of units there who have said we want Drupal. Yale did not offer Drupal, so they've gone out in the wild and paid consultant X or hosting company Y. So there are people out there in the Yale community who are taking advantage of Drupal, but not internally. So sometime in 2009, somebody somewhere picked Drupal and said, this is going to be the enterprise content management system for the university as a whole. It's our standard. You guys go build it. In terms of them telling us the business requirements behind how we're going to build it, or why we need to build it, and what functional requirements we need to meet, we got some ideas in terms of target audience. They did tell us that they expected there to be thousands of sites. But then they also had these sort of high-level abstract components that make up a Drupal site that they expected people to be able to deliver on. So kind of make it easy for a person to say, I want blog functions in my foo.yale.edu Drupal space, or I want calendar, image gallery, brochure site. There's several of these sort of high-level things that they said, we need to make it easy for customers to say they want this. We sort of took those requirements and sat on them for a while and needed to also think about things that they didn't state that we needed to make sure we took advantage of. So we have a MySQL Enterprise install at Yale that powers the institutional calendaring service. We run beat work there for the Office of Public Affairs and the Secretary's Office. A lot of time and money was spent building an enterprise robust MySQL Enterprise infrastructure there. So we certainly need to take advantage of that. As far as authentication is concerned, we certainly knew that we needed to take advantage of the campus single sign-on infrastructure there. We currently use CAS, which was actually written by Yale many years ago, but a lot of higher ed campuses take advantage of CAS, the central authentication service. And it's sort of a mishmash of things that were stated that we needed to be able to provide, but we also thought would sort of empower the customer, the user, in terms of owning their site. They needed to have some level of privilege that allowed them to do things, not give them a very dumbed-down jail or anything like that. So end users certainly needed to be able to receive administrative-like powers to configure their Drupal sandbox however they want to do. So as I mentioned before, we're really, really interested in sort of pushing it to the limit, even though we're not Facebook. We like to sometimes act like we are, and sort of take advantage of the hotness wherever we can in order to deal with fault tolerance. So regarding high scalability, we certainly saw multiple ways in which we could primarily take advantage of work that other people have done in order to make Drupal scale. Drupal powers a lot of high traffic sites, MyHouse.gov, whatever it may be. Other people have sort of conquered this task, and we needed to be able to reuse their work. Regarding where we would choose to perform those optimizations, we certainly saw the opportunity to perform enhancements at the framework level, so within PHP. We could certainly do things there in order to eke out performance, in order to scale more. We found that we could certainly take advantage of cache mechanisms at a reverse proxy. So being able to sort of cache objects downstream at the reverse proxy that customers did before they actually get to an application server. But then we also found deep in the back end that we could also institute other cache mechanisms at the database layer in order to alleviate load of the database. Yeah.
Sorry, you talked with reverse proxies, talking like putting squid in front of Drupal or something like that and having it cache.
Yeah. So
are there any issues with that?
I'll talk about.
Sorry.
That's okay. I'll talk about sort of decisions about what to do with the reverse proxy. But yeah, it's that same sort of right. Yeah. So the other thing too, since this was sort of going to be a very big thing, we certainly thought it was a necessary imperative that we have a version control system to take advantage of all the code customization that's going to be going on. Source control management or version control systems at Yale, there's a whole lot of them. People take it, but there's no SCCS, but there's certainly RCS, CDS, Subversion, and this was certainly one of those projects. There's going to be a lot of code flying around, and we needed to deal with that. Especially since there were going to be multiple disparate teams that were responsible for contributing together glue that was going to sort of make the thing work as a whole. I'll talk a little bit more in detail about that final bullet point in terms of how we organize version control in order to deal with vendor branches. So the other thing we knew we needed, or we figured we needed, would be deployment tools. Something that would allow us to tell a system, or to have somebody who's not us tell a system to say, go build this. So there's really sort of 4 reasons why we thought that we needed these deployment tools in order to make this happen. Is to make the customer happy in terms of getting them bootstrapped very quickly. That same sort of customization of Yale-ish code that lives in version control, we need to be able to distribute that out in a sort of routinized manner, or in a way that we can make happen very easily. Drupal is powered by not only Drupal core, which is the tarball that you download from Drupal.org, but also like user-contributed modules, like the Facebook module or the Twitter module, whatever. Yale Drupal would certainly take advantage of a core set of modules that would power Yale Drupal, and not only does core get updated, but these modules get updated. So we need to be able to accommodate the Facebook module being upgraded from 1.0 to 1.1 sites out in the wild. And then of course vulnerabilities too. When there's a vulnerability in Drupal core or whatever, we need to be able to get out there and patch machines, patch stacks very quickly. And if I'm going too fast or you have a question, stop me before I move on. So we thought about things that certainly would fit. The ability to provide total airspace segregation for people in terms of them getting a dedicated machine that runs their own lamp stack with their own instance of the framework and all that other sort of stuff. That certainly stinks, especially if we have to meet this order of magnitude of 1,000 systems. We don't have any space in the data centers, and everyone, especially the customers, are broke and certainly couldn't afford a solution that's powered by that. The other thing that we thought about too was, well, let's try to be as hands-off as possible. It will essentially be our job, or the job of the deployment tool, to just explode the tarball and hand the user the ability to rampage over to install.php or some sort of other not very customer service friendly way of saying, here's your site. Without talking to anybody else, we certainly all agreed that that was a far cry from good customer service. We also found out that people have that now in certain places right now. People can get a hold of like OpenBZ containers or VMware containers and do that themselves, and they're not happy with it. They want more. They want it to be really sort of easy. So that's certainly one. On the topic of sort of deployment tools, anything that involves us doing anything intricate or delicate or anything like that, we know certainly doesn't work because I'm expensive and so are my colleagues, and us doing intricate, delicate things doesn't work. And moreover, we make mistakes. As long as we tell the machine what to do in a way that's not full of errors once, it should never make errors as you allow the customer to think of. The other thing we looked at too is Drupal has a dependency on a relational database. So in an effort to sort of provide that relational database component, there's a couple different ways you can do it. You can either choose to have a one-to-one relationship between your Drupal sites and a relational database on the back end, or you can take advantage of table prefixing, where everyone sort of shares credentials but prefixes their tables in a way that's unique to their site. So the tables that power the foo site are prefixed with foo, and the tables that power the far site are prefixed with far. It's certainly easy in terms of the sort of sprawl you have on the back end. You do sort of win there with prefixing, but we sort of did not think that that provided sufficient enough airspace segregation, because the idea here was that the Chinese Students Association would essentially be sharing the ability to get at the office of the secretary, or sort of things like that. So there are going to be these sort of very important person offices, or these sort of people that you don't want their site to in any way be compromised. But then the idea was that this same sort of service offering would be made available to student organizations, including the Hacker Club, who want to move in here. So we didn't think that prefixing and doing the shared databases was a good way to go. Another solution you can do with Drupal, and it's really cool, but we ended up not using it, this notion of multi-site. So you can essentially have one tree of Drupal sitting out there on the platters of your application server or servers, and the topology of the directories as essentially power the namespaces that get served on the front end of the application server. So you can have a directory called foo yell at you and a directory called bar yell at you. They share the same code base, but you're able to serve like name-based virtual hosts in both namespaces or whatever. It's certainly cool and limits your sprawl of code on disk, but this is another one of those airspace segregation problems here, where we thought that that's sort of my second to last bullet point here in terms of code being shared across the Secretary's office versus the Hacker Club. The first one's really important though too, is that there's no room for cowboys at Yale. So we're really paranoid about change control there. So the idea is that you essentially should not be touching something that you don't need to touch unless there's a compelling reason to touch it. We certainly didn't want to have constant turnover in the code base that powers customers who've been living there for 2 or 3 years. There's risk involved with touching a shared Drupal core tree that powers everybody as time goes on. Especially if you're going to make architecture changes and decisions 12 months into it in terms of how you do business. The other thing we were sort of afraid of too, or was in the back of our minds, is what if this notion of Yale Drupal forks? It certainly wouldn't surprise me if that sort of happened in terms of what the standard offering is. With multi-site, you're sort of locked into an instance of application server or application servers that run version 1 of multi-site, and if you sort of fork out what it is, you end up having a sprawl of application servers for version 2 or version 3 as functional requirements change for different customers. And then we also hear Drupal, but that might be so this is sort of the crux of how we did it. The idea here is that we would, within version control, would certainly have a shared code base and the maxim that we had to beat into many different people in terms of how this works is that we move code upstream and content downstream. What this means is that the customizations that power the template behind the Secretary's office, or Facebook module 1.1, and all these other things that are Yale Drupal-ish, of course, make their way upstream across various branches broken down by environment. So what this means then is that we can have a branch in version control that's sort of this core cadre of ITS web people who aren't me, can pick and choose between Facebook modules and Twitter modules and change the rounded corners from blue to green or whatever it may be. They sort of live in this high turnover development environment where all manner of customers have their customized bits live there. And the idea is that as they would bake those functions, they would request on some sort of change control schedule the merging of that data upstream to a more important branch, and then of course deployment to application servers from that non-dev branch. Yeah.
Are you allowing your customers into the development tree, or are you?
Not at all, and that's the second part of the towards the end of the slide deck. Yeah. So I'll talk. So no. So there's sort of small group of sysadmins who were sort of in charge of building this up. They certainly have the right to where they can choose to write within various places in the version control system. And then there's maybe a dozen people that work for central IT who are web technologies like people who have the ability to change the secretary's rounded corners to blue to green or update the Facebook module from whatever. So as sysadmins, we primarily never touch these branches unless we're performing a merge operation upstream to production or something like that. But the web team, those people live in there 8 hours a day, 5 days a week, in terms of just constantly committing changes and deploying all that. So regarding how we move the code upstream with distributed version control systems, you can certainly choose to push or pull. We decided that we didn't want to use this. Essentially, we wanted to leave the ability for us to commit some sort of emergency break fix to this production branch and deploy it very quickly to production application servers to solve some sort of remote root or vulnerability that needed to be patched right away and put out that fire. And then once the dust settles, we can merge that emergency break fix downstream to development and things continue to move upstream as the business as usual. Regarding content, so the idea is that content bits flow downstream. So all sorts of things that make whitehouse.gov look the way it looks in terms of paragraphs and image tags and all sorts of things that make it look the way it does, all that food lives in the database, right? So the idea is that pages and nodes and configurations of modules and all that stuff live in this sort of relational database. So what I need to be able to do is take that database downstream to non-production environments in order to do all manner of good things, including that final bullet point of testing with production. So if you have a very disparate amount of time in between revision numbers between the last time you touched the Secretary's office 6 months ago and now, you really need to be able to test that. So, but yeah, so I'll say, okay, let's go ahead and refresh, this 6-month-old revision for the Secretary's office. Deploy that to, sandbox test but not production, and then let's go ahead and bring the database down, and then let's go ahead and merge their content upstream and deploy that and see if we survive an upgrade. So there have been a couple of times where this has actually sort of saved our butt in terms of just blindly pressing go and letting it deploy. In those instances where you have a very giant amount of time in between the last time you touched the production customer stuff. So yeah, so we can certainly bring what we've built allows us to bring that database downstream, and then if we choose to, we can also cherry pick revision numbers or whatever from version control and deploy those in order to get a bit for bit like copy of what runs in production outside of production to test it. So this is sort of details about how we did it. Sitting on the front end, everything's powered by name-based virtual host and Apache, which of course means that we don't support SSLs of transport for customers, and things that has been pretty clear in terms of this is not a place to put, what Yale calls relock data, with the most sensitive amount of stuff. You don't get buffer, but any NSF ramp bits and all sorts of things like that. That certainly is Yale Drupal's not a candidate for storing that data, and the community is sort of aware of that. I'll talk about authentication in a second in terms of exchanging authentication information. The other thing we sort of do too that's kind of cool is that there's really no automation to how DNS is managed at Yale. You have to go hail a troglodyte at a desk and have him update zone files and reload zones for you. And so that, of course, takes time, and customers don't want to deal with that. So sort of a decision point was made within Yale to say, okay, let's sort of pick and standardize on a unique namespace, and we'll, of course, serve a wildcard for that, and which would allow us to in our case, we chose Site-CLEDU, which allows us to deploy Hacker Club Site-CLEDU at 8 a.m. in the morning. And of course, with the DNS wildcard, Hacker Club Site-CLEDU is available to you at 8:01 or whatever. You don't have the DNS turnaround. But of course, a lot of people, I will say that a lot of customers who are like the Secretary's office or whatever, that certainly isn't an elegant looking domain. It doesn't look good on a business card. So a lot of people who are important, tend to pick sort of top level domains. But yeah, your ability to pull that up quickly is contingent on how you choose to manage DNS.
All these sites are accessible from the internet?
So what we've chosen to do is that I'll get to it in a bit. But it's all
Okay,
fronted with F5 load balancer. But what we've chosen to do is expose tests in production to the planet, development, sandbox, and everything that's not that is not only accessible on campus.
Okay.
Do you have a question?
You kind of hit it.
Okay. Yeah. So yeah. Regarding configuring the framework, one of the things that we chose to do, because we're sort of nobody wants to end up on the front page of Yale Daily News. So how do we sort of provide that? Everyone's sharing the same application service at this point, right? We're not sprawling pizza boxes for every customer, but we still want to be able to make configuration changes at the framework in order to mitigate risk of information disclosure and leaking data that belongs to customer A via customer B's PHP calls or vulnerable code or whatever it may be. So one of the things, I'm totally not a PHP expert, but one of the things that I thought was really cool and I learned a lot about in undertaking this project is that PHP has a function called open-base-dir, which effectively is like a chroot in terms of accessing paths on a file system. So what we've done is within the name-based virtual host configuration bits for Apache, we set admin override values for PHP that set that base-dir restriction to only allow fooey-ledu to get at fooey-ledu's docker and deeper, various like pair and PHP library junk that you have to expose to a site in order to work. And then another thing I'll talk about later is letting them get at what Drupal calls files, which is binary attachments to nodes. This is my presentation.pdf attached to the presentation page. That's of course not stored in a relational database. The binary itself is stored on the disk. So by only exposing those sort of things, there's really no way that my presentation PDF should ever get exposed via the framework, via the hacker sources.
As long as the code is good, because they're moving your code, not via the interface. This is not a real true.
Right. No, I totally, yeah, so within the framework itself should not allow you to get at my...
We made a slightly different decision because of that.
Say what?
We made a slightly different decision because of that.
Okay. What was the different decision?
From multiple patches.
Okay.
As non-privileged IDs.
Gotcha. Yeah. So that's regarding what the core is within Yale Drupal. You can certainly go grab the tarball from Drupal.org, and a lot of people choose to do that. There are many flavors of Drupal. One of the things we found is that there is a distribution called pressable, which is really amazing and gels really well in terms of our obsession with scalability and fault tolerance and all this other sort of stuff. So there's lots of food that it allows, that it has plug and play function with, that we really wanted to be able to hit the ground running with the initial service offering, so we chose this. It's also very actively maintained too. Sort of within the framework, we make extensive use of PHP accelerators. So we chose APC. What APC allows you to do is essentially perform those two functions outlined under that bit about APC. It allows me to take extensively reused PHP calls and have the bytecode already cached so that I alleviate taxing PHP. Not to say I don't tax PHP by having APC there. Certainly it's a hog, but it certainly helps us in terms of trying to scale this out. The other thing we sort of do too is talking about the reverse proxies is that we make extensive use of what's called the RAM cache module in our F5 load balancers. So we have a pair of 6400s that we've run lots of services with, Drupal being one of them. And internal to the tool, internal to the F5 is the ability, the pair of F5s is our ability to slice out some space and allow binaries to essentially be cached there. So in our case, it's like JavaScript and style sheets and images and all sorts of other stuff that eventually make their way to cache on these reverse proxies. Not to say that if you don't have a hardware load balancer, you can't do this. If we did not have these, I think we almost certainly would have picked Varnish. One of the cool things that I learned about Drupal and Varnish and other sort of stuff in doing this project is that some really smart guy somewhere has essentially written a module that allows Drupal to phone home to Varnish and tell it to flush its cache based on certain rules and patterns that you want to tell it to do. So what's really cool about that is that if you did have Varnish downstream and you deployed fooey.ledge, you could essentially on deployment have Drupal call Varnish and say, go ahead and flush all your cache objects for fooey.ledge. That's really cool. So
How are you handling that problem with the F5?
don't. So I don't know if I talk about this later, but there is certainly an API called iControl that's available for the F5s.
Yeah.
It's very hard, learning curve's very steep, and we haven't sort of solved that problem.
So just to clarify, you administer the F5s?
Yes,
Okay, that'd be nice.
that helps. That certainly helps, yeah. So what else here too? And because we don't make those API calls, we set the time to live on the cache really small, so like 5 minutes or something like that. So
You don't have the applications to change quickly yet.
not that quickly.
The applications changing on a second basis.
Yeah. So other sort of components we did in order to sort of help meet our desire to deliver something that's certainly scalable. Memcached has been around for several years. Yale's never used it before, but so this is our first foray into taking advantage of Memcache. So Memcached combined with the extension, the PHP extension for Memcache, and a Drupal module that drops in perfectly with PressFlow for Memcache allows us to have sort of a second tier of service that we can provide to the admissions office or to Yale Edu if it moves into Drupal or if it moves into Yale Drupal or whatever. The Hacker Club, because of the complexity involved with instantiating these bits, I shouldn't say instantiate, because it's pretty easy for us to say fooey.ledge edu gets Memcache. But owning that configuration complexity, we certainly don't want to give that away to everybody. So it's really sort of an opt-in service that we can make available at the point of deployment or even after the fact. If the biology department finds out that they're on the front page of CNN, we can sort of swoop in with this using configuration management in order to help alleviate all the CNN click-throughs to the biology department's website for n number of days or whatever it may be that we're seeing an immense lot of traffic. So just some sort of details about how we chose to configure Memcache. It essentially is plug and play with PressFlow. So we cherry-pick very popular, very often hit tables within Drupal and chose to stand up Memcache bins for those. We set the algorithm, I forget what they call it, but there's two configuration options that you can cherry pick within Memcached in order to determine how it hashes, in order to determine within what bin on which application server the object lives in. We made that choice due to speed. I don't know why I said complex. But then like how we actually do it. We make extensive use of CFEngine too, so we can essentially if it's a known configuration that's going to need to run that way all the time, we can instantiate it at the point of deployment or whatever. Or if it's a temporary break fix for that biology department who's been slashed on it, we can, within CFEngine, drop in a couple of configuration bits to say, go ahead and make sure that we run these Memcache bins for this customer site. We point PressFlow to the bins with include files that we have made available to all customers. So essentially there's a configuration directive within Yale Drupal customer sites once they're deployed that says, if you contain the magic Memcache PHP files or whatever it may be, go to these Memcache bins because they belong to you. Nobody has that file until we say, oh, biology needs it, let's go ahead and make sure configuration management, CFEngine, pushes that bit to the biology department sites and also instantiate the bins, and then at that point, the biology department now has the necessary bits that Drupal will plug into the bins, and the bins are running, and it just works. And then another component that that is done too is that subsequent deployments, if they're sort of a permanent Memcache customer, those bins get flushed at deployment. The only other thing I would say about how we chose to do it is that this means that you have to have some sort of planning upstream internally. In the same way, if you don't use centralized authentication and you use local accounts for Unix machines everywhere, and you want to make sure that your UID matches your UID everywhere or whatever, you have to sort of have that dummy table that's somewhere on some machine that says, oh, you know, Silkey is UID 5.2 everywhere. We essentially, we're in that business of managing the bins. So in terms of, we know where the bins run, but on which specific ports the bins run belongs to a certain namespace. So we have to own that sort of bit of data in the back of our heads or in version control, in version control for our documentation behind the scenes to know that biology owns the bins on these ports. The only other thing I'd say too, for anyone who doesn't know much about Memcache or how it works, there's internally like no sort of authentication bits here within Memcache. So luckily for us, no one's allowed into version control to allow them to say, yeah, let's go ahead and make a bunch of PHP calls and bind all, you know, all 65,000 ports on myself, and let's go slurp all the data in the bins. Certainly someone could do that if this were a PHP cesspool. So it assumes that you have some sort of control to stop bad code from being able to get into the bins. They can poison the bins and also sort of read the data there and flush it too. So, but the benefits certainly have been a risk in terms of how we chose to control the environment. The other thing I talked about was files. We have multiple application servers in multiple environments, and certainly direct attached storage won't work if we need to store my lecture.pdf for customer foods website or whatever. So what we've chosen to do is take advantage of our tier 2 storage, which exposes NFS exports to the application servers. We've chosen to break it up per environment. So we assume that there's crazy code that may live downstream that somebody is sort of hacking and slashing on. And then also the open base tier stuff that I talked about before sort of attempts to restrict within the framework the ability for site B to get at the path for site A's files. Scales really well, regardless of your number of horizontal nodes. So Drupal is very smart and won't write collide. And then upon successful write, the data is available to be served from all the application servers in terms of reads. So how we build it. I keep talking about deployment, and there's lots of different ways to sort of do it. The first one, of course, is Apache Ant. Apache Ant, we're a little bit abusive in terms of what it was built to do in terms of how it could have been used to build, you know, Yale Drupal or whatever. But we already have a significant chunk of Ant in place within Yale because we're a heavy Java campus. That also leads us to the potential to integrate it later. We certainly looked at Capistrano. At the time, there was like 0 Ruby on campus, and so we thought that a cap install would have meant that Drupal would have been sort of the only customer. Moreover, Yale's always 5 years behind. So like, you know, Drupal's been around for quite a chunk of time. Yale had a little bit of apprehension about going with Capistrano as a way in order to perform these builds on these machines. So that, of course, explains that. And there's also Ager, which is an interesting project that's coming out of the Drupal community that attempts to sort of solve this problem of reach out and touch build-ups, reach out and touch updates, all sorts of things. When we looked at it at the time, it was very early, sort of young code. Nobody was really using it in production. We didn't consider it viable at that point. My colleagues back at the University of Texas are doing the sort of same thing now in terms of, hey, we're picking Drupal as the institutional CMS, and we need a tool that allows us to sort of do this. From what they tell me, Ager's gotten really mature and really grown up in the last, it's been about a year since Drupal's been around. So, but at the time, it was really immature and wasn't really viable. So, I already spoiled it for you, but we chose Apache Ant. The way it's sort of implemented there, or how it works in a day-to-day world, those 12 people who work on that sort of web technologies team who constantly have code turnover in that development branch have the ability to call Ant to say, go ahead and build my dev site for Ledger or whatever on dev application servers from the dev branch, whatever it may be. They really love that. It used to be they would SFTP a bunch of files around, and the ability for them to have consistency as code moves upstream. They really dig on that. Regarding how code moves to production application servers, you can't trust developers to perform deployments to production application servers. I'm sorry, but you just can't. They're a different breed of people, and they don't really care about change control and dealing with risk and disaster. And so, release managers certainly facilitate those deployments. One of the things that's really cool about this is that the way we chose to build this with Apache Ant, we've completely abstracted away the notion of database credentials. No one ever knows them, and no one ever really cares. What I mean here is that, the user and password that's required by Drupal in order to bind to its relational database on the back end, or perform reads and writes to its database back end. We don't really know what they are. The dev guys don't really know what they are. We have a convenient, cool, reproducible means to sort of hash those values out. And we also sort of seed them with predictive entropy, which allows us to change out that seed data and swoop through and reset database access control credentials on anybody should anything leak, or should that bit of entropy leak and the hash algorithm leak too, or whatever. If that sounds really obscure, you can go ahead and wipe it. You can dump core right now, but if you want to know more about it, I can talk to you more about it. So it's really cool. So the other thing we chose to do too, we're the only non-Git fanboys at Yale. We actually chose to implement this entirely in Bazaar. One of the major compelling reasons to do that is the web team said, man, we have this monster list of modules, right? We want all 77 of these things to be made available in the altar. Anybody who's worked with vendor branches in Subversion knows that it really sucks and is a pain in the butt. And we sort of realized that if we had chosen Subversion to be the version control system that backs all this, it would be very hard for us to externalize the instantiation of new vendor branches that contain the Mevo module, and also updates to the vendor branch that contains the Mevo module to the web team, right? Because they're not very technical people, they're rounded corners kind of people, right? So because of that, we thought that Subversion was a no-go, and so we looked at sort of better, more modern version control systems. And I had previous experience with Bazaar in Texas, and once we sort of mapped out how we could do it here at Yale, it really was really easy, and it really is just simple. In hindsight, kind of going back and looking at how the code base exists now, I think we're by far the most ridiculous version control install on campus in terms of vendor branch complexity and vendor branch count. So we really made the right decision in terms of over time people say we want this module, this module, this module, and I think we made the right choice. So it also integrates really well, regardless of what sort of platform you live on. If you're one of the rounded corners people, you work on a Mac or on a Windows machine, whatever, Bazaar just sort of plugs in and just works. Moreover, they're not the only people who live within version control. We keep a lot of sort of utilities within the same version control system, including all the Ant stuff and more stuff I'll talk about. So this is simply sort of a high-level diagram of what powers the infrastructure here. I think I've talked about most of it already. So. Another thing that we take a lot of advantage of, there's a tool that comes out of the Drupal community called Drush. It's also known as the Drupal shell. It's really amazing stuff in terms of your ability to perform sort of command and control functions or administrative functions on a site in a sort of batch command line predictive way rather than click this, click that, or whatever. It's really sort of amazing. What it can do, flush cache internal to Drupal, We can both read and write various Drupal variables in SQL. The other thing that we do is that we sort of stage authorization for new customers. The idea is that, you know, Professor Blowhard wants RatLab SiteCLG or whatever. Let's go ahead and stage Professor Blowhard's SSO credentials, SSO NANID to have this sort of administrative function within the site. So as soon as it's up there, we're done and you can have it. We can immediately sort of log in. The other thing it does too is that it sort of maintains or reinforces this authorization, and it also is responsible for standing up Drupal's features. What features are? Features are off the chain, so it's a module from Drupal. What it allows you to do is sort of, it's almost like configuration management for a given Drupal site. So it allows us to sort of have a series of known good configurations that we want applied to a given namespace, and combined with another module called StrongArm, let's go ahead and enforce that config. So that the configuration of the CAS module, which is our SSO for Yale, we instantiate all the configuration directives for that module and point an SSO, and we StrongArm it, which keeps them, Professor Fu, from going through and changing that to something arbitrary and breaking himself, or changing it to something bad, or whatever it may be. And the only real kind of takeaway from features is that it's really awesome to bootstrap something right away. It's absolutely terrible it's great at building dependencies to turn something on. It's terrible at walking the dependency tree back down to tear something down. So I will say that if you're looking for a way to sort of pre-stage a bunch of configuration directives for a given site, we kind of acknowledge the shortcoming of features that it is a one-way street, that we can sort of build something up, but then we can't rely on that same sort of simplicity and ease to tear that down. So, it's tough to read. Yeah, it allows us to very quickly go through and blast a bunch of modules on that are part of the known good configuration, and then also like have them configured. So that essentially is how we go from this, which I think everyone who's ever used Drupal has seen, to this in about a minute. So let's see. So here's kind of like a workflow for how things work for a new customer. So somebody who's new in terms of a namespace, right? So, you know, Professor Fink's RatLab.SiteCLG never existed before. He wants in. So what essentially Ant does is it goes and grabs, it exports code from production branch in Bazaar. It goes ahead and it bootstraps the necessary Apache virtual host config. It bootstraps the necessary docker bits on the file system on the application servers. It goes ahead and pushes the data that it exported, explodes it. We go ahead and clean up this notion of restricted themes, which is a bizarre business requirement that came downstream after the fact, but it essentially allows us to sort of have vetted customer data available to vetted customers only and not to the hacker club. It's really unique. If you want to know more about what that is, ask me. We go ahead and we bootstrap the necessary settings PHP bits that make Drupal work from templates and Ant runtime. This is where we have that divination of MySQL database credential bits. We use stored procedures internal to MySQL that we created to allow us to instantiate the database should it not exist, and it shouldn't because it's a new namespace, and then set the necessary access controls on that database to allow Professor Fink's RatLab to bind. We push the necessary schema for Yale Drupal into that database. We bootstrap all the Apache bits that are required to power Professor Fink's website, configure the files bits to point at the NetApp. We do the switch. The switch means that we're swapping around a bunch of symlinks. This is similar to the workflow of Capistrano in terms of a symlink for current, pointing at your most recent Revno build or whatever. We pull out our utilities from Bazaar, which from utilities we make extensive use of calling Drush to stand up features, set site name, blast the Drupal private key so it gets regenerated, flush the Drupal cache, push that staged authentication data off Apache. It's up. Sort of what we do for existing people. So Professor Fink's site has been up and it works great, but there's a vulnerability in Drupal, or there's changes to the sort of core module, core templates that the web team wants to reach out and touch every customer with, or whatever it may be. It's very similar. The slides are on your USB stick in terms of sort of what's different. This is all very much the same, except for Let's see, it's a lot of validation stuff, right, except for the last two bullets where we go ahead and say, okay, let's go ahead and take a current database snapshot before we actually perform any sort of deploy writes to the database. And then let's go ahead and take the site offline, which puts it into Drupal maintenance mode. Then we do the switch where we flop around, we roll current over to prior to point at the old rev node, and we point current at the most recent rev node that we just deployed. A lot of things are the export utilities is the same. At this point, we then, Drush will rampage through module updates that may have come across as part of this deployment, which means that they need to extend the schema or block some new tables for the Facebook module. Drush will facilitate extending the schema for us. Flush the Drupal cache, that's all pretty much the same except for the last one. Upon successful build, we put the site back online, and it's pretty cool. So, what if you deploy poison code or code that's broken? One of the reasons why we get in the business of managing assemblies is so that we can switch it back really quickly. So what we can do is, have it roll this back, say, oh no, let's go ahead and rip current down, point it prior, and let's take advantage of that database snapshot we just took and push it back there in case, if we molested the database with extensions or whatever it may be, and now we're back in business. Then how you sort of do the post-mortem after the fact, you, like I mentioned before, being able to take content downstream in addition to code, we can then take the existing database that lives upstream for the site that we just bricked and take it to a non-production applications server or servers, and also bring the code downstream that exists in production in that environment. And now you have an exact copy of what was in production that you just bricked and you just rolled back in this non-production environment that you can now sort of come to the web team and say, all right, now you're free to perform deployments to this, debug your code, right? Figure out why, what got merged upstream, changes from you that got merged upstream, great to say. It's really cool. Yeah, I think we're actually doing all that. So.
How often does that happen?
What happened?
Where you
Things
have to roll
breaking?
back?
We actually had one happen last week. Before that, it had been several months. So,
And how long does it take?
to roll back?
Yeah.
Under a minute.
How are you doing that quality assurance to, is this an obvious can't talk to database kind of error message?
Yeah, so usually when things are really bricked in Drupal will display like the white screen of death, which basically it renders nothing to you. Usually means that there's a bunch of PHP errors in your PHP error log on the application server. So release managers sort of perform the initial sort of simple test of, holy cow, like I've white screened, let's revert this. And then at that point, you're free to sort of bring that content downstream and then come to the web team to debug it. You look surprised.
I don't know enough about your release manager to know how it knows it got a white screen.
The release managers are us. Unfortunately, we don't have like
so
QA.
naked eye is what we're talking about.
Huh?
Naked eye, you're actually
It's us.
okay.
Yeah.
You're human. Okay.
That's right.
I understand that.
Yeah. So one of the things that the pressable fork allows you to do is take advantage of simple tests. We're not currently using it, but it's the ability for you to write unit tests or whatever for a given namespace, which you could then call with and post deploy, and even have, oh, I failed my simple test targets. I need to go ahead and call my rollback targets in order to put me back, remove the human out of the loop. So we'll get there. There's currently the human eyeball lift at that point. Other things we've done too, after the fact that I haven't really talked about. There's a whole lot of like configuration options in terms of cache behavior and how you want to configure your topology in terms of reverse proxies within Drupal PressFlow. Things sort of got off the ground, customers moved in, we said, wow, we really need to turn this all the way to 11 or turn it back down to 5 or whatever it may be. Now we need to go out and sort of touch everybody and sort of reset those values. Apache Ant certainly allowed us to sort of do that in terms of sweeping out to every known customer deployment and enforcing performance variable settings on all the given customer sites. Another thing too is that for one reason or another, we had a bunch of MyISAM tables for some of the early Christian sites who moved in. We make heavy use of IB backup in order to perform these backups, and there's a whole lot of other reasons why we prefer MongoDB over MyISAM. There's really no full text search need for Drupal itself. or we've not encountered any sort of module that needs that full text indexing that MySim gives you. So it was, oh no, we have n number of customer sites out there with various MySim tables. What do? Oh, we can take advantage of the deployment tools in order to call targets with an ant that go out there and rampage through the storage engines for those tables and convert them for us, which is really cool. So we, early one morning we went ahead and advertised that we were going to do this. Tiny blips of outages as we rampage through our customer site and perform the conversion. It was done in about 15 minutes. Really cool. The other thing we do is sort of like that lifecycle management of that authorization in terms of auto roll. So being able to reinstantiate someone who loses authorization to their given site, and also to solve that problem of the grad student who's graduated and gone back to Korea, and now nobody has the administrative credentials to sort of maintain the Korean student club website or whatever. We can have lifecycle management of authorization there. So this is an example of sort of how things have evolved. See, August 2009, things were ready for prime time at that point. We really had sort of a working workflow. This is a visualization of dependencies with an ant. With an ant, anyone who's ever used it before, you're essentially telling it, it's a very sort of, you define targets within it and notate dependencies of targets within there so that it has a build order in terms of, oh, I have some dependencies. If you were building software with it, it's very makefile-like. If you wanted to, oh, I need to go ahead and make sure I build dependency A, B, C, D. If I succeed in all those, build a new package, whatever. When I'm done, make an RPM or whatever. And it notes, builds successes and failures of targets. So in August 2009, things were pretty well baked. This is sort of how it looked. 2 months later, they said, oh, it'd be great if you could add this feature. Oh, it'd be great if we could sort of do this. It sort of looked like that. 2 months later, it's getting more and more scary. This is sort of how things look in February. This is where we've bitten off the ownership of, wow, we need to go ahead and enforce a bunch of configuration variables or convert the tables or whatever. We've instantiated the targets, which contribute to this looking like spaghetti. They're not actually completely used. I think they all live up here. That sort of, here's your sort of main build workflow. 99.999% of what we do day to day sort of. It looks scary, but it's really not. We wrote it, we maintained it, we documented it. To prove it's not scary, we recently hired a new sysadmin. Working with her for an hour, she sort of got this, which I thought was really cool. I was worried that she wouldn't be able to, but it really sort of does just kind of make sense and is easy to maintain. So you can get changes to her, and she's able to sort of pull it off, and it sort of passed the litmus test of spaghetti or not spaghetti. So we keep saying it. I've already sort of talked about these acrobatics, I think, in terms of things that we've done after the fact. Where we're going with this, I think I have about 4 minutes. So how we want to make this better or what we're going to do. Currently, ants call interactively, which is part of that whole vulnerable to mistakes, all sorts of reasons why you don't want to do that. We really want to take advantage of continuous integration tools in order to perform a lot of these functions for us. There's a huge presence of Java on campus where a bunch of J2EE dudes need to build WAR files and deploy WAR files and all sorts of other stuff for JBoss and Tomcat. We want to take advantage of Hudson, which is being stood up to meet those needs, to also sort of be abused to help with the Drupal workflow. We want it to solve a workflow problem within Drupal. It really sort of does provide like a click infrastructure to allow the web team who does deployments to development. Who knows, we might be able to sort of get away or be able to punt this to a real release manager who doesn't have to fire off a bunch of cryptic ant commands. What else? Here's the more than ITS needs to be able to commit to version control problem where you have the Department of Food who says, hey, I got a dude on staff who knows Drupal. I want him to be able to create my round of corners for me or sort of whatever maybe. A lot of customers are happy, but then there are some customers who say, no, we need to be able to write to that version control system up there. So let's see. So regarding our bazaar install, it doesn't really work very well in terms of authorization within certain components of the tree. It's kind of an all or nothing thing. We have very simple modes and file access control lists in terms of allowing you to write. And we really don't want to own the complexity of n number of developers who need write to go with a bunch of disparate UIDs, GIDs, access control lists, whatever. So how we're sort of going to solve that. PHP 5.2, the takeaway now as of whatever month it is now, 2010, being a Drupal user or whatever, 5.2 is almost a necessity. We're currently running 5.1, and it continues to be more and more of a problem as stuff goes on. The open source reverse proxies are easier, like I mentioned. You can very easily make API calls with the Drupal module that's maintained by other people in order to flush, varnish when you do a deployment or whatever. We need to be able to do that without control later. So to solve that version control problem, what we're proposing to do is that within Subversion, Subversion really rocks because we've already solved the authorization problem within Subversion. There's a sort of institutional source code management system at Yale powered by Subversion, which allows us to have granular authorization within it to only allow the rounded corners guy to perform writes to the templates directory or whatever it may be, so he doesn't make PHP edits to Drupal core. So sort of where we're going with this and what we want to do is that we want to have a Subversion branch within Subversion that gets refreshed nightly from Bazaar. And then those power users who want to be able to create their own rounded corners in their own Drupal site, they'll get a branch in Subversion. And then we'll take advantage of Subversion externals to keep their branches up to date with a nightly refresh, which means that templates, so use externals plus authorization for rewrite where needed. Yes, so they can only perform writes to their templates path where they're going to create their rounded corners and change green to blue or whatever it may be, but they won't be able to perform writes to modules or core within their branch. And then of course the continuous integration Hudson stack will allow their branch to be monitored upon commit and allow their commits to, here we go, allow these we call them power users, these people who want to be able to have write the version control, allow them to sort of check out from their branch, they change green to blue, whatever it may be, right? They're going to do something more intricate than that. But they work on their local map or LAMP install on their machine, test. Ah, looks good, I need to be able to commit this back to their branch. They commit it to their branch. Hudson watches their branch, deploys their code to their namespace on a development application server, and they sort of verify it. So this allows us to sort of solve the sandbox problem that everyone says, I need a machine, or I need to be able to see my changes on a Yale machine in the data center. This sort of solves that problem. And then we sort of have the same sort of workflow to sort of bubble those machines, those changes upstream. So the power user deploys this stuff. Hudson deploys the power user's changes in his branch to his dev application server. He says they look great. He hails a branch manager. Of course, the branch manager will take advantage of the Subversion plugin within Bazaar to pull those changes in that Subversion branch up to development and bubble those changes upstream all the way through production. So the other thing we want to do too, we're looking at the idea of providing database slices, database snapshots to customers to allow them to take their given running configuration of their site as it stands now, or nightly, or whatever, and be able to suck that into their local LAMP, MAMP, XAMPP, whatever it may be installed that they're currently working on in development, so that they have something more meaningful than Normos or whatever. The only thing we're worried about there is sort of the risk of leaking that. We couldn't have done this by ourselves. We took advantage of a consulting company out of Austin called Four Kitchens. They're really great. I don't speak for Yale, but if you need help, they're great. So that's it. That was a whole lot of data. Does anybody have questions about it? Yeah. So it's pretty cool. Essentially when they said you guys are going to build, you're in charge of managing enterprise content management for the university or whatever. How do we do this without really having to do anything? So we did a lot of work up front, and it really is just sort of robust in dealing with faults and can perform sort of new write actions very quickly. Is this a problem that people have now? Oh, my university picked Drupal too, and I don't know how I'm going to do it. So So we sent a couple people to DrupalCon in San Francisco a few weeks ago, and it was the web guys, the rounded corners guys, and they came back, and they said, you know, holy cow. Apparently, at DrupalCon, all they were doing was talking about, there was a bunch of higher ed people, right? You know, every single higher ed campus, every tier 1 campus, yeah, we picked Drupal, you know. But some people have been doing it for a while, like Arizona State and other people. Everybody sort of talks shop about how they do it or what they did in order to sort of build it out. And the web guys came back and they're like, wow, you know, out of all the stuff that's being done or whatever at all the different universities, like we're probably on the list of like top 3. Because a lot of people build stuff out and then they have no like lifecycle management of the code, right? They just kind of blow it out, set it and forget it. And before they know it, they have 200 customers out there and you have some sort of vulnerability and you need to be able to reach out and touch them. And the way you blow up those sites was highly interactive. And you're going to have some dudes sit there all night. And, you know, whatever. Maybe they said, yeah, out of all the different ways to do it, they think that this sort of architecture is one of the top 3 best ways that they'd seen any higher ed institution take advantage of like institutional improvement. So that made us feel good that we like made the right decisions. So anybody who uses it, I'm happy to like, answer questions, email or in person, about like architecture design, decision points, growing pains, whatever.